Jai Hind to all. This is Engineer Priyanka SAINI. Now today we will start system in lecture 3. As you can see, what is system? A system is defined as the entity on one or more signals to accomplish a function to produce new signals. As you can see on the picture, input signal given in a system and we got output signal. The types of input and output signal is depend on the type of system being used. Now these are the examples of practical signal: communication system, control system, remote sensing, biomedical, signal processing and auditory systems. Now next is classification of system. System has 5 types. First one, this system can be continuous time system as well as discrete time system. First one is linear and non-linear system. Second is time variant and time invariant system, causal and non-causal system, stable and unstable system, and last is static or dynamic system. Now we will start from linear and non-linear system. Linear. What is linear? Linear, a system is to be linear when it satisfies the superposition theorem. Superposition theorem or principle. What is superposition principle? Superposition principle consists homogeneity and additive property. And let us consider two continuous time system, y1 and y2. In continuous time system we consider two signals, y1t and y2t, which is function of x. y1t is the function of x1t and y2t is the function of x2t. y1t and y2t are the responses and x1t and x2t are excitation or inputs. Then a continuous time system will be called a linear system if it satisfies the following expression. What is the expression? Expression is function of a1 x1t plus a2 x2t equals to a1 y1t plus a2 y2t. You can see on the diagrammatic picture, which is principle of shows as a principle of linearity. First diagram shows when x1t and x2t, these are excitation or inputs given in the mixer mixed with a constant a1 and a2, and output of mixer a1 x1t and a2 x2t goes in adder, and we got a output a1 x1t plus a2 x2t, and after this output goes in system, and we got yt. It is called response, is equivalent to this diagram. In this diagram we gave input directly in a system x1t and x2t, and we got y1t and output y2t. These are responses, and mixed with a constant a1 and a2, and after this output of these mixers goes in adder, and we got yt. Both diagram are equivalent to each other. Non-linear. What is non-linear? If it does not satisfy the superposition principle, is called non-linear system. Okay. Next is time variant or time invariant system. A system is said to be time variant system if an input signal results in corresponding time shift in the output. If this condition is not satisfied, then the system is called time variant system. You can see on the equation yt equals to function of xt, and a shift in input, we get shift in output, same shift in output, then the function of x t minus t naught equals to y t minus t naught. A continuous time system is said to be a time variant system if it does not satisfy equation 1. Next is causal and non-causal system. A system is said to be causal system when output depends on present and past value of input. That is called causal system. A non-causal system is when output depends only on future value of input. Condition of causality is ytm equals to function of xt when t is less than or equals to tm. Non-causal system do not satisfy equation 1. Next is stable and unstable system. An initially relaxed system is vivo-stable if and only if every bounded input produces bounded output. When bounded input produces bounded output, then the system is called stable system. Condition of bounded or stability: mod xn less than or equals to mx less than infinite. This is for input, and for output is also mod yn is less than or equals to mi less than to infinite. Next is static or dynamic system. A system is called static when output depends on only present value of input. That is called static system. Static system is also called memory-less system, and dynamic system depends on past and future value of input. It is also called memory system. Now we will discuss the problems on these properties. First problem is yt equals to txt, second is yn equals to n xn square. In this problem, we will check the linearity. For linearity, first we will take x1t and x1t goes in system, and we get output y1t, and y1t is yt is given txt, then y1t is t x1t. Same, the value of x2t equals to y2t. After coming from system, y2t equals to tx2t. Then y3t equals to combination of both outputs y1t plus y2t. We will put the value of y1t and y2t, t x1t plus t x2t. This is the value of y3t, equation 1. Okay. Next step is we will put the value of input in the combination of both inputs x1t plus x2t. Was in the system x1t plus x2t, we have put equals to x3 dash t. When x3 dash t coming from the system, output is y3 dash t, and yt equals to given value is t xt, then y3 dash equals to t x3 dash t. What is the value of x3 dash t? x1t plus x2t. Put this value x1t plus x2t, right? Then the value is tx1t plus tx2t. This is the value of y3 dash t. Equation 2. As in previous slide, you can see y3t equals to tx1t plus tx2t. Both equations are equal. When y3t equals to y3 dash t, then the system is called linear system. We will check linearity by this method. Next question. Next problem was yn equals to nxn x square n x square n. This is your assignment question. You have to solve itself. Next problem is for causality. Check causality. Yn equals to xn plus nxn minus 1. Xn is present value and xn minus 1 is past value. Then the system is causal or non-causal? This is causal system because output depends on present value, present and past value of input. Then this is causal system. Next is yn equals to x2n. x2n. We have to check this value by put the value of n, different values of n. How can I solve this question? Yn equals to x2n. Put n equals to 0. Then the value is y0 equals to x0. Present value at this time, it is causal system. If put n equals to 1. y1 equals to x2. Output depends on future value of input. N equals to 2, y2 equals to x4. Also, output depends on future value of input. So, for 0 value, output depends on present value. For positive value, output depends on future value. We will find for negative value, n equals to minus 1. Then y minus 1 equals to x minus 2. Minus 2 and minus 1. Minus 2 is past value and minus 1 is future value. So output depends on past value of input. Then for 0 value and minus value, output depends on present and past value. And for future value, for positive values, output depends on future value. So for positive, negative and 0 values, this system is called causal system, and for positive value, this system is called non-causal system. equals to AXN plus 6. This system is stable or unstable? This is stable system. How? When we put the value of Xn, then we find the stable value of output. Or what is stability? When bounded input produces bounded output. When we bound the input, we give the value, any value of input, then we bound the output. It is called stable system. E to the power xt, e to the power xt, e to the power xt is also called stable system. Why? Because xt, when we put the value of xt like 1 or 2, then we find a bounded value of output. Why? Because exponential value, I think exponential has some numeric value, then we find a bounded, finite value of output. It is also called stable system. Check static or dynamic system. Yn equals to 3xn plus y. Xn is present value. Then output depends on present value of input. Output depends on present value of input. Then it is called static system. Static or memory less system. इसमें कोई memory नहीं होती है. Next is dyt upon dt plus 10yt plus equals to xt. This is static or dynamic? This is dynamic system. Why? Because it is used in this equation differential of output dy2 upon dt. Due to dyt upon dt, it is dynamic system. It has some memory. It is also called dynamic system. Okay. Now this is our last category of system. In next lecture we will start jet transform. Thank you.